Good afternoon, ladies and gentlemen. My turn to share some memories and thoughts about these early days of computer graphics. And I will try to cover the stories between INA, so the really early days up to the beginning of the 90s in TDI, knowing that my focus will be more on the technology, the process, than on images, while we are going to share some images anyway. So I think it's interesting to come back at what was the world in 1981, which seems, when you look at that, a bit far away. Can we imagine a world without PCs? Okay, they came, if my memory is correct, around the years 82 or something like that. It was a world without Macintosh. Can you believe it? It was a world with very limited support and knowledge of Unix, which became really the operating system and the programming environment of choice later on. This being said, there was a Unix community, obviously, which was mainly American and Australian, and it was possible to start as we experienced. So the computer world was mainly about IBM mainframes and mini-computers. And the mini-computer which has really triggered the development of 3D computer graphics in the US in the late 70s was the famous PDP-11 from Digital Equipment Corporation. The PDP-11 then was replaced by the VAX, and the VAX family was really the family of machines which has allowed the growth of computer graphics in the US in the late 70s. Of course, there was no Silicon Graphics. There were still students, I think, at that time. And if my recollection is correct again, I think the first usable Silicon Graphics workstation appeared most probably around 1984, something like that. On consumer electronics and TV, the world was also very different. There was no digital TV. TV was analog. Digital TV was a subject of studies and perspective. It was something which was experienced in several European labs and American and Japanese labs. But of course, no digital TVs meant no CDs, no DVDs. So the world was really on VHS, on tapes, for dissemination of content. Obviously, and that's maybe the most important, there was no internet. Internet did exist, of course, but it was something pretty confidential. But, of course, the TCP/IP protocols did exist and did allow people to exchange programs and data across computers. Believe me, it was not that easy at that time, but you could do it. All that was pretty dark, let's say the dark age. Then, at least my perception of it, then light came. Light came from Monte Carlo. Monte Carlo, Imagina, was the event which brought the perception and the understanding of what was happening on the other side of the ocean. In the US, from everything that people like Ed Catmull or Jeff Blin or other pioneers started in the late 70s. And it was fascinating. For young guys like me, it was really a revelation. And I was thinking, typical French, well, if they can do it, I can do it. Okay? And we started that way. So really considering that this was really the new frontier. We had nothing, we had no hardware, we had no equipment. Okay, it was not an issue. We were going to find a solution and we are going to make and to trace our own ways. So at that day, I was working at INA. INA is a national institute. In France, it's a National Institute for Audiovisual Communication. In fact, it was a former, among other things, it was a former research organization of the former French broadcasting organization, the equivalent of the BBC on the French side, which was cut into 7 pieces, if I remember well, in 74 or 75. So INA was a national institute, and that was important because there was no real sense of profitability. And basically, you were a researcher in this place. It was great. You could do basically what you wanted to do. Of course, you were supposed to spend time. You were supposed to invest energy and goodwill. And after all, the management at that time was satisfied by that, as long as they perceived that you were not a clown and you were not really wasting your time. They were expecting good things to get out of this kind of process. So I had what is finally the most important rare resource, time. And that was, I think, the fundamental factor. Free time or time available to invent things and to discover things. The other resource which was existing at that time was a frame buffer. Something which was really uncommon, which was a 512 by 512 by 24 bits frame buffer. Oops. And this kind of equipment was something which was really, really uncommon. It was more important to have access to a frame buffer than to have access to a computer. Because computers, you could lease computer time. You couldn't lease a frame buffer. In 1981, at least, which was when we started. Since we had no computers at that time, it could appear to be an issue when making computer graphics images, and it was an issue. We solved that by leasing time, so hiring time, paying for time as a service, if you want, on remote computing centers in universities, academic centers. So that was an easy solution. And of course, we could display the result of the programs on this famous frame buffer. So we started that way, and pretty soon we built a 3-guys team. So we were 3. Alain Nicolas was working on the 2D computer graphics programs before. Daniel Borenstein, who started as a sound engineer and moved pretty quickly to special effects for films, on various films, both working on sound and on visuals and images, and me. And we spent most of our time, days and nights as well, of course, writing software in 92, 93, 94, during at least 2 years and a half. And during these 2 years and a half, we put together basically a pretty solid rendering program, at least 3 or 4 generations of it, but it has been the foundation for everything which has followed this story. So this rendering software was really the foundational piece. Surface modelers, polygonal modelers, trajectory editors, animation software, so I would say more standard stuff. And we added, let's say, textures, materials, and what I call semi-real-time user interface, because at that time, let's remember, we were working on basically mini computers and screens without a real-time 3D visualization capability. So a lot of limitations on the user interface. So very slow user interfaces. And this forced, at that time, the development to use a lot of tricks to make the process, I would say, doable and productive, even without the support of 3D real-time visualization. Not easy. And then, I would say, July '94, we issued our first, and I think it is the first TV jingle which has been used on the TV channels, the French TV channels. It was for TF1, and then quite a lot of other products have followed in 94, 95. So let's have a look on what was the production of our team, the three of us, in 94 and 95. These are the images that I produced when I was still a producer. After that, I satisfy myself with pictures which were produced by my friends and clients, which is a different perspective. Because at the end of 85, we realized in the INA team that the limitations of the structure were way too important for us to continue that way. And then we had to find another environment, another business model. The opportunity came with a merge with a team which was coming from the flight simulator division of Thomson CSF, so they came from the military world. They had access to resources which were several orders of magnitude larger than the ones we were used to. But they were also fascinated by the filmmaking, storytelling, picture making, and so on and so forth. So we found that we could create something interesting together. We merged the teams and we created what became TDI, Thomson Digital Image. At the same time, we had let's say, a fundamental choice to make between what used to be the legacy of computing and high-speed raster displays and everything, and a new paradigm which was emerging, which was SGI. SGI was bringing to the world something which was new, radically new, which was a kind of all-in-one solution. Within one workstation, you had everything, which was not the case before. It was more disintegrated. SGI brought the computing power, the 3D real-time display, the interfaces, the Unix operating system, everything, at least in our perception at that time. So we decided to shift everything and to port and to rewrite quite a bit of the software to optimize it for SGI. And that kept us a little bit busy in 86, if I remember correctly. At the same time, the production work developed, and it became pretty quickly apparent that if we were to be able to continue investing in technology and supporting a team which grew up to 6 to 10 engineers, which was heavy at that time, it was necessary to consider licensing the software to others, which we started doing second half of 86, if I remember well. And then, quite clearly, we entered into this usual issue, which is that it's not advisable to compete against your clients, and in this case, to license your software solution to a production company, and having your production department competing with this third-party company using your software. So the situation became unmanageable pretty quickly, and we had to separate the two aspects, so system design, software development, and computer graphics production, and this became Ex Machina. So I will let Xavier develop much more what Ex Machina has produced and the story that they have developed. During these years, a lot of investment was put during the very early days of TDI as a focused company, a company focused entirely on the development, marketing, and licensing of software packages. We had to transform what used to be an internal set of tools, so an internal production tool, into something which became a commercial package. And this commercial package has been named Explore. It inherited, of course, all the best of INA and TDI early days stories, plus a number of big additions, very important additions. Georges Lacroix has mentioned Arctic, which was the first commercial package allowing people to deal with skeletons and animated characters in a meaningful way. We had something which became extremely important, which were interfaces with the CAD/CAM world, and a number of advanced features here and there. And I would say we also added the not so big things, but not so small things neither. So a number of things which made life easier for the Explore users. And remember that at that time, life was tough. Everything was tough. Before the introduction of fonts, for example, in commercial packages like Explore, fonts were really a punishment. Another important thing which was introduced at that time was the users group, which was an organization which became soon, very quickly, extremely important, which allowed users to organize themselves and to play a very significant role in influencing the company on where to put the development effort, what to develop, and how to set priorities. So the dialogue with the Explore user group has been something which has been extremely important. Then came success, pretty significant in Europe and in Japan, not that much in the US because let's remember that most of the other packages, so our competition at the time, was American and Canadian. Success in production, in animation, of course, but also success in in visualization, in card design, in card visualization, with mainly three really power users, three very influential users, which were Mercedes-Benz, here in Stuttgart, by the way, in Zendelfingen, not very far from here, Renault in France, and Honda Motors in Japan. So Honda, Mercedes, Renault were the three big guys which really bet on this software package and on this team. And culmination, let's say, 91, we learned, several years after, but we learned that we were number one worldwide in shipments in 3D computer graphics software. So if I were to have known that at the time, I would have been very proud and happy. But Silicon Graphics did everything to hide that, because they had some vested interest with other companies at that time. But this was another story. Then came what will be my last slide on this story. Very big thing and a lot of problems at the same time. We introduced what has been called Explore version 3.0. Version 3.0 was an incredible technology challenge. we introduced in particular two things which were both representing a very big leap forward in technology and in some dimension in vision about what computer graphics had to be. The first one was IPR. IPR was interactive photorealistic rendering. The idea was quite simple. At a time where people spend a lot of time, so a lot of time in lighting, in fine-tuning materials. I don't say it's that different today, but at that time it appeared to be really monstrous. We wanted to bring a solution which allowed people to re-render only those pieces which were modified in a 3D scene. So basically the concept, you know it, but I rephrase it for the sake of precision. The concept was to pick one point on the screen, okay, and having kept in a buffer all the information on all surfaces behind this pixel to be able to re-render only those parts of the shaders which were affected, okay, using the interaction tools which were provided. The original idea, I must say, came from a guy named Georges Lacroix, the third row there, from Phantom, and let's say the fundamentals of the design of the feature were designed on the napkin, as any great idea in computer science, I think, as a napkin effect. So this was developed and was brought to the market in late 2001 to late 92. The problem was that this feature exceeded by too far, to be really honest, the capabilities of the hardware at this point in time. And I've been amazed earlier this year, so in 2009, to discuss with guys, and okay, there is no reason to, there is no confidentiality aspect here, with the bakery team, so the guys who have set a quite interesting lab near Marseille in the south of France, which have developed, former PDI guys, who have developed a relighting tool, which amazingly is IPR. And we are in 2009. So this says, and they did something which is great. They did a very great software with, of course, a lot more than in the 1992 edition, and a tool which I think is bringing a lot to long feature film production. But what is still amazing is that this functionality, which was introduced as a commercial product in 92, is still introduced in 2009 as something which is leading edge. And this tells two things. It tells, point one, that yes, we were visionaries at that time, and we were in advance in our time. And second, it proves that we were way too much in advance on our time. If you are 5 years in advance on your time, you're a great guy. If you are 15 years in advance on your time, you're just wrong. And I think we were wrong at this point in time. And I must say we paid it the hard price. The other point, which was a heavy addition, was NURBS modeling. So here too, I think it was less ambitious, since NURBS was a geometric representation which did exist in the industry at that time. It was the first time that this was really introduced with full, I would say, ambition to the animation world. In my opinion, this was too heavy. So the level of sophistication and intrinsic power of the NURBS modeling was, in my opinion, was just not really necessary for what we need in 3D animation and visual effects. That's something which is really only needed in advanced industrial design, and that's most probably something which has introduced a lot of weight and burden to the package in 1992. Also, again, considering what the hardware was capable of in 92. And then we run, not surprisingly, into a number of business model issues. And our shareholders at that time wondered first, is animation a serious market? Okay. Is it a market which can grow? When you consider the question today, it's a bit funny because it has not grown, it has exploded. But this was very difficult to predict at that time. What was considered as a reference in the early 90s was really the industry, the industrial design. CATIA was a reference for success. And the tricks and recipes which made the success of CATIA were really the tricks and recipes that had to be followed by everybody, at least in the opinion of the heavy industry and the big bosses. So Thomson tried to engineer an alliance with IBM using TDI as a vector for this alliance. This did not work. Then Thomson sold TDI. TDI was merged with Wavefront. Wavefront was merged and bought with Alias. The whole was purchased by Silicon Graphics, who later sold everything to KKR. KKR later sold the whole package to Autodesk, and here we are. This is a bit an accelerated version of the history between 1992 and 2009. And that's the end of this early part of the story. Thank you very much.
We have time for a few questions. Anybody has one? Yeah.
I'll repeat the question.
Est-ce qu'il peut raconter comment il faisait une image à l'INA d'abord?
So Pierre is asking if Jean-Charles can explain how he computed an image when at INA. Comment? Oh, how he viewed an image at INA.
You love the story. Well, okay. Let's remember, at that time we had no computer, but we had a frame buffer. We had not only a frame buffer, but we had a frame buffer coupled with a step camera. So a step-by-step 35mm camera. So the process was the following. We had a 1200 bits per second line, which is not very, very fast, between our place and the place where we had the academic, the university with the academic computer center, 30 kilometers more or less between the two. So we are programming through the 1200 bits per second line, so telephone line, and accessing remotely the big computers. When we were ready to launch, to compute an image, so we said, go. Okay, so the job started at the other side of the line. And the result of it, an image or a sequence of images, was stored 30 kilometers away. Then the next step was to take a small company car, Renault 4L, okay, and then 30 kilometers driving, getting the pictures on a big computer tape, taking the car back 30 kilometers, taking the tape, loading the tape into the frame buffer, and then shooting the images on the step-by-step camera, right, for animated sequences. And then the point was it was a development process, so you need to manage an iteration loop in a debug process. If the image was wrong because there was still a bug or something which was not working properly in the software, then you had to modify the source code, recompile and everything, and then relaunch the process. 30 kilometers multiplied by 2, 60 kilometers. Okay, with traffic jams, we are in Paris. Okay, so the traffic is pretty bad. We had basically placed for 2 tries per day, one morning, one afternoon. The amazing thing is that it forces you to program with very few mistakes, believe me. Today, programmers have the real-time debugger in another Windows. I can navigate from one bingo to the other one, so it's really, it's amazing. But at that time, before, the very nice thing about the story is that before really deciding, okay, we compile and we launch, we double-checked, we triple-checked the whole story very, very, very carefully. It was not that bad.
Thank you.
Thank you.